Hey there, everyone. My name is Brian Reed. I'm excited to be presenting the session today, Insider's Guide to Mobile AppSec with the OWASP MASVS for the Pacific Northwest OWASP Conference. Sorry we're not there in person, but I'm pleased to be able to record this and participate in the event. Hope to see you all in person sometime soon. So a little bit about me. I'm the Chief Mobility Officer at NowSecure. I've been doing more than 15 years in mobile, dating back to the first mobile security platform, as it were, which was BlackBerry. And over those years, I've worked for a lot of different organizations in growing mobile AppSec, secure mobile applications, containers, devices, and all the rest. NowSecure is an automated security testing and pen testing company. We literally wrote the book on mobile forensics about 11 years ago. Our security research team has created tools like Frida and Radari that you might be using, and we work a lot with every kind of commercial vendor or government agency in helping make sure that their mobile apps are secure along the way. So enough about me, let's get on to the topic. So NowSecure has worked with OWASP since the inception of the OWASP Mobile Project, more recently the MASVS that we're going to talk about today. And if we kind of think about the context, almost 70% of all digital traffic and time spent on the internet is actually with mobile. But in our annual benchmark of millions of mobile apps in the iTunes and Google Play App Store, we find about 85% of all mobile apps fail one or more of the OWASP top 10, about 70% leak private data. So the statistics aren't great. The good news is we have millions of mobile apps in our pocket. The challenge is we don't all have the skills we need in order to get those apps tested properly, and I'm hoping to help you develop your skills today. So I'm guessing that a lot of you may come from the web world, and mobile AppSec might be new to you. So this is oriented around learning more about mobile AppSec and understanding the overall environment. So a couple of things for us to start with. So we know there's two different mobile OS with varying security capabilities. There's 4 development languages. You've got Swift and Objective-C and so on and so forth, dozens of frameworks, thousands, tens of thousands, hundreds of thousands of libraries. We also have a much faster update rate than a lot of other technologies, with generally big OS and OS library updates going on every year. Unlike mobile apps, where about 90% of the code runs behind a firewall in a web app environment, mobile apps run in the wild on a device that's easily reversible, as we're going to see today, and largely unprotected. So that drives a different set of strategies for mobile app secure development as well as testing. And we're going to take a look at how the OWASP MASVS can help us sort of tackle some of these differences between web and mobile. So thinking about the mobile attack surface is part of the story, right? So when we think about what can go wrong or what can go right, we want to look at code functionality itself and how all the code is written. We want to look at data at rest. Remember, in storage on the web world is a little bit different. Storage on a mobile device is highly likely to be reversed, tampered with, or otherwise visualized. Data in motion over the network is a top attack vector and surveillance vector. Of course, it could be runtime issues, and every mobile app talks to a back end. So what's going on between the mobile device and the back end is important. And so as we think about the attack surface, let's kind of move on into mobile app security testing sort of 101 and the things we need to know. So when we kind of decompose this down into mobile AppSec and testing, right, from an app security perspective, the OWASP Mobile Project has a ton of resources for us. We're going to go through those today. We think of mobile, we're going to be talking about iOS and Android and a little bit of IoT with mobile connected apps to the device. If you think about testing, there's a lot of different testing strategies and tools, but you will need a combination of static and dynamic. You will want to look at the binaries, not just the source code. And remember that the device and the mobile app aren't the same thing. So let's look into the OWASP Mobile Security Project itself. So it's all available on the Git repo. There are links here for you to get to all the components. The OWASP Mobile Top 10 is what most people know. That's where it all got started. Same with the Web Top 10, and we now have an OWASP API Top 10, and so on and so forth. But over years, the project team, including NowSecure and others working on it, realized that we needed to go much deeper, that the use of mobile was now pervasive, and we needed first-class application security knowledge and testing capabilities education and tools and all the rest. So the MASVS and the MSTG were created. The MSTG is your detailed testing guide with checklists to accompany it. The MASVS is really a way to learn and better understand threat modeling and security requirements for mobile, and that then drives into how to test mobile. And so we're going to take a deeper look at the MASVS today, because once you understand the MASVS, you can step into the MSTG and run through the checklists. So the foundation of MASVS is really a four-part application security model. So let's talk through to understand. What this really is classifying different kinds of applications based on the threat and the sensitive data and the IP all used in those applications. So at the lowest level is L1. It's considered a standard security level. There are no compliance or regulatory needs, and they can be very simple applications. So for example, we'll use a healthcare example to look at the four different levels. So if we think about like the WebMD app, that's basically look up information about, what is a particular disease, or when I have a boo-boo, how do I fix it, or, things of that nature. And so it's not very high risk. It's very general. There's no PII. There's no login or authentication. So that kind of fits our basic L1. Now, L2 is the next level. That's defense in depth. And it's very important to recognize that if you have regulated industry data, if you have compliance issues related to that regulated industry, and you may be doing simple apps, but you have sensitive data. So a nice example of this might be like a healthcare weight monitoring app, right? So there's some PII because it's, the person and their weight, and they wouldn't want that to get out. There may be some other, collected health data in it. But it's pretty simple because it's doing a single thing. So let's make sure that we test at that level, which is a deeper level, L2, than we had in L1. Now, there's a concept called resiliency, and that's really has the app been hardened, anti-tamper proof, and so on and so forth. So we can take L1 and L2 and then add resiliency. So why do I need resiliency? Well, generally, resiliency is about IP protection. Remember that mobile app on that mobile device can be 100% reversed. It's not like a web app sitting behind a firewall that has all the perimeter defense. So in here, we're trying to prioritize IP protection, but we're also trying to prevent malicious tampering that could change the behavior of the app and possibly cause negative things. And so let's imagine like a medical formulary app. Maybe I'm in healthcare space and I'm a doctor and I want to understand particular drug prescription levels based on a person's height, weight, and age, for example. We wouldn't want them prescribing the wrong thing at the wrong level. And so while the app itself doesn't have PII or patient data in it, it could be disruptive, if not fatal. If the formulary gets screwed up, like what level of dosage. And so we want to make sure we prevent that. And we're going to lock that down by applying resiliency, and then we're going to test for that resiliency. And then we have L2 plus R. So now we're talking about defense in depth, right? This app has regulated data, sensitive data, and so on and so forth. It's more sophisticated, and it can perform complex activities with highly sensitive data, and IP protection is required. And so when we think about this, you don't want to have malware attacks. You don't want to have man-in-the-middle attacks. There's a lot of things that could potentially go wrong that could be life or death oriented. So if we think about like a healthcare drug delivery app, like let's say I have a digital app and it's connecting to an insulin pump. And so the last thing in the world you want to do is have that app be manipulated in a way that could kill a patient by injecting too much insulin or not enough insulin. So it's kind of our ultimate. So here's our four different areas to think about. And with an understanding of this, really from a threat modeling perspective, we can start applying techniques that are relevant. So L1 fundamentally really expects a standard set of security best practices that we'll have a look at today. L2 expects really a hardened type scenario. So should probably be using certificate pinning, other network protection capabilities, multi-factor authentication requiring a device passcode, things of that should be included in L2. We'll look at that shortly. R expects hardening, right? So obfuscation, anti-tampering, device binding, and so on and so forth. And it's very important to recognize that while you're applying resiliency capabilities, most things can still be bypassed by the most advanced actors in the market. So make sure that your app is secure. Don't assume resiliency of hardening the app is going to protect against an insecure app in the first place. Reversers will find their way through it, especially the nation state or the more committed they are. And so hopefully you have a better understanding of these four differences, these kind of four areas, and we can think about how do we apply them. So within the MASVS, there are 8 domains. Unlike the OWASP top 10, it's a more logical breakdown, and there's best practices guides, threat modeling, and understanding for all 8, from architecture and design and how to build a threat model to storage and privacy, cryptography, authentication and session management, network communication, environmental interaction on the device, because there's a lot that can happen on a mobile OS. Code quality and build setting, we find a ton of issues there. And then finally, that reverse engineering type capabilities in V8. So we encourage you to learn about V8, all 8 of the domains. Given the short time we have today, what we're going to do is we're going to dig into the top 5 areas we recommend you focus on. Now, these top 5 areas are actually the result of our years of pen testing and analysis of millions of apps in the app stores, looking at where are vulnerabilities most frequently found in the wild. And so we can kind of work backwards from, if we can pick the 5 areas where vulnerabilities are found most often, let's focus our testing on those and develop our skills around those. And hopefully as security professionals work with a development team to develop better skills. So the first one and the worst one is data stored in an insecure and exposed location. Now, from the MASVS mapping, this is actually V2, 3, and 6. Not only are we looking at data storage, we're also looking at crypto and some of the environmental interactions that can lead to insecure data storage on the device. So from a development perspective, they should be careful about the code they write from the perspective of encrypting sensitive data, avoid writing or storing sensitive data, take advantage of APIs like Android storage is actually Android libraries to help with this. Be careful of query strings and so on and so forth. And so from a testing perspective, then you want to be testing for credentials and PII and the files and the logs and IPC. There's a lot of places where data can leak on a device. One of those places is when an app can run in the background. So remember, apps can switch from front to background. Well, that background information is still capturable. So you want to make sure the screen blanks and memory blanks, when that app shifts to the background. We find as many as 25, 30% of applications have bad or old crypto libraries or reuse crypto in an insecure way. Make sure that the app is requiring that the device has a password on it, right? The passcode on the device will help further protect the application itself and reduce some of the chances of tampering. And of course, if you're coding on Android, use the Android scope storage is the best way to do it. That's why Google built it in the first place. So number 1 is insecure storage. Number 2, and the next most common area we find issues is around insecure data communication, right? So that's classically V5, network communication, and some things around environmental interaction on the device, and the device APIs related to network communication as well. Remember, network communication can be over HTTP and your TCP/IP and your Wi-Fi, but it could also be Bluetooth to an IoT connected device. So make sure that your developers are generating TLS sessions only after validation of the trust scenario. Cert pinning, if you're doing regulated data and super highly sensitive data, you really have to do certificate pinning. As testers, that means we also need to know how to test certificate pinning in multiple different ways. What's good news is in more recent years, iOS and Android have added default network security libraries. So on iOS, look for App Transport Security or ATS. On Android, network security configuration as well. And then finally, man-in-the-middle attacks can happen, and they can be pretty horrendous. We find a pretty high man-in-the-middle attack rate when we're doing testing, and that can be the result of multiple different things. So as a tester, test TLS, cert pinning, zip files in transit. Zip files in transit can lead to the man-in-the-middle attack. You should be looking for sensitive data transmitted. Look inside the TLS tunnels. Make sure all the communications are over HTTPS. Cert pinning can be bypassed a number of different ways, so make sure you test for valid certs, signed certs, unsigned certs, improper certs, and so on and so forth. It's great that we have ATS and network security configuration, so check for use of those. You can set up your SAS to look for that as well to support you. And then the other important thing is that we find as many as half of these vulnerabilities actually occur in the third-party libraries, open source or otherwise, that organizations use. So make sure not just your own code is secure, but code coming from third-party sources as well. And if you're doing binary testing, you'll pick up the third-party libraries during dynamic testing on binary, of course. Doing network testing, there's a little bit you can do in SAS, but really just means you need to develop your dynamic testing capabilities, skill sets. So moving into number 3, insecure authentication or authorization. About 14% of apps have this. That's good news. As we drill into this more specifically, making sure sessions are properly terminated, make sure no app data is visible when a session is ended, discard and clear the data, running authorization checks and so forth. So as a tester, you should look at session validation and data in memory as part of your process. For insecure coding practices, there's about 47% of applications have that, and that's really V6 and V7 around environmental and code quality. One of the most important things for testing and for the developers, making sure the appropriate keys and certificates are using at the right time in the right way. Proper hashing operations and error handling. Error handling is often a place where vulnerabilities are found and exploited. So test to make sure the mobile app itself is signed with a valid cert. Look for debug builds and hard-coded keys. We find that a lot. Make sure you test for error conditions in overly verbose log files that could be logging too much information that could be used to attack your app. And of course, third-party libraries come through here. Last thing is reverse engineering in our top 5. So about 32% of apps suffer from reverse engineering or are reverse engineerable. Now, most iOS are not as easily to reverse engineer, so a lot of these tend to be Android apps. So leverage third-party tools, especially for Android. Good news is that Android has a safety net API. Make sure that safety net API is being used to check before as your app loads to make sure there wasn't Android device tampering or otherwise. There's lots of ways to prevent reversibility or slow down the reverser. So the app should be detecting jailbreak and rooted conditions, should be detecting whether a debugger is loaded and trying to review the code, whether there's any data file or manipulation. And basically the app should defend itself against those. Look at string tables and methods as well, not just the strings, but the methods against them. And again, leverage the safety net API. So some key takeaways today in our fast drive-by of the MASVS is, recognize the differences, take advantage of the mobile project, start exploring. There's a ton of resources in the OWASP Mobile Project to work from. Build your skills. I'm going to share some toolkit guidelines, learn about threat modeling. The MASVS will help get you there. The 8 requirements really do help us break down how to do this as a best practice with MASVS and then into the MSTG. And start with the big 5 we talked about today: storage, network, authentication, code, reverse engineering, and tampering. And we'd love to have you get involved in the project. We have a number of people at Now Secure and our customers involved. Please join us to participate in the program as you develop your skills as well. As a final takeaway, I got a handful of resources for you here. First set of resources really is if you're trying to build your own kit. There's a whole set of assets here. So the Mobile Security Project resources, including a hacker's playground, which is quite helpful. We recommend Frida and Radari. Those were actually created by our security researchers. They're great as you advance your skills, especially for on-device testing. You'll need network testing like burp or Z-attack. You'll need jailbroken and rooted devices, and there's lots of other tools you can look at there. If you want to automate your testing, there's some great commercial software from Now Secure. We've got a workstation, which is our pen testers toolkit. We've got platform, which is a fully automated environment. They use SAS, DAST, IS, and APISec that cover the bulk of the MASVS. You can run in automated or interactive modes, and it's really a bootstrapper that includes embedded remediation. It makes it easier to find them. That's something the MASVS is missing, is actually good remediation instructions for your developers. Some other resources for you here. So we've got a whole first-timer's guide to the OWASP Mobile Security Project. You can download that. The top 5 issues I talked about today are dissected in this infographic further. If you want to set up your own program, we have a guide. And if you're really into digging in, we're pleased to have built and provided to OWASP a CrackMe for the Android side of the house. You can leverage R2 Frida and some of the other tools to do that as well. And that's in the repos over in OWASP land. So take advantage of these resources. Reach out to us. Once again, I'm Brian Reed, and I love mobile AppSec, working with OWASP and developers and security analysts together. You can find me at br@nowsecure.com. That's my Twitter handle as well. Look forward to following up with Q&A or hit me offline anytime. Thanks, everyone. Goodbye now.